Every summer, the same ritual begins. You walk to the thermostat, you lower the number. Somewhere outside your wall, a machine hums to life, drawing power, cycling refrigerant, spinning motors, consuming electricity, and your utility meter begins its quiet, expensive rotation. You have done this so many times, it feels like the only option that exists. It is not. Right now, sitting in an industrial supply catalog between pipe fittings and pressure gauges, is a device that has been commercially available for decades. It costs less than a single month of your summer electricity bill. It has no motors, no refrigerant, no moving parts of any kind. It requires no installation appointment, no certified technician, no annual maintenance contract. And the moment you connect it to a source of compressed air, one end becomes cold enough to freeze moisture on contact, while the other end simultaneously becomes hot enough to burn your hand. Same device, same moment, same air. Here is what should genuinely anger you. This invention is not new, it is not experimental, it is not waiting for regulatory approval or final testing. It is 100 years old. The physics behind it was documented before your grandparents were born, and for every single decade since its discovery, some of the most powerful manufacturing companies on Earth have been quietly using it inside their facilities, while the industry selling you refrigerant cycles and maintenance contracts has had absolutely zero incentive to mention it exists. This is not an accident. This is business. And it started with one physicist, one metal pipe, and one observation that the scientific establishment desperately wanted to dismiss. Paris, 1931, a government laboratory. George Ranque was not trying to revolutionize cooling. He was studying compressed air behavior in industrial systems. Routine work, expected outcomes, nothing that suggested history was about to be made. Then his instruments showed him something that made no sense. Air was entering his metal cylinder from a single inlet. That same air was exiting from two separate ends, completely ordinary so far, except the temperatures at those two exits contradicted everything thermodynamics said should be possible. One end was producing air cold enough to form ice crystals. The other end was simultaneously producing air hot enough to cause burns. No chemical reaction inside the chamber, no electrical mechanism separating the temperatures, no refrigerant evaporating to absorb heat, nothing being consumed, nothing being added, just air entering a shaped metal space and leaving as thermal opposites. Ranque verified it, repeated it, rebuilt the setup, and ran it again. Every single time, the result was identical. The physics was not malfunctioning. The physics was doing something nobody had ever engineered before, separating thermal energy through geometry and motion alone. He filed his patent. He published his findings. He stood before the scientific establishment and showed them data that should have launched a revolution. The establishment looked at his data and reached for the most comfortable explanation available. Measurement error, they said. Instrument malfunction. Unusual conditions. The effect, even if marginally real, is too small to matter practically. Move along. Nothing here worth serious investigation. Ranque's discovery was not disproven. Disproving it would have required engagement, testing, genuine scientific curiosity. Instead, it received something far more dangerous than disproof. It received indifference. The patent was filed. The papers were shelved. And one of the most elegant thermal discoveries in engineering history quietly disappeared into an archive, while the world continued building bigger, more expensive, more chemically dependent cooling systems that someone could profit from maintaining. Understanding why the scientific community rejected Ranque requires understanding how institutions protect themselves. Science is not a collection of curious individuals freely chasing truth. It is a social structure with reputations, funding dependencies, career hierarchies, and deeply embedded assumptions about how the world works. When a discovery fits comfortably inside existing frameworks, it moves quickly. When a discovery challenges those frameworks, the instinct is not celebration. The instinct is resistance. What Ranque was showing violated the intuitive understanding of thermodynamics that every physicist in that room had built their career upon. Cold does not simply appear inside a metal tube. Heat does not spontaneously organize itself to one side, while cold concentrates at the other. These things require external energy inputs, chemical processes, mechanical systems. A hollow cylinder producing both fire and ice simultaneously from a single airstream felt less like a discovery and more like a magic trick. And scientists, correctly, distrust magic tricks. The problem was that the appropriate response to a suspicious result is rigorous testing, not dismissal. What Ranque received was dismissal dressed as skepticism. The difference matters enormously. Skepticism investigates, dismissal ignores. And what gets ignored does not get corrected, refined, or developed. It simply waits. For 14 years, the Vortex Tube waited, a German research laboratory. A physicist named Rudolf Hilsch picks up a forgotten paper from 1931. Unlike everyone else who had encountered Ranque's work, Hilsch did not see a measurement error. He saw a phenomenon worthy of serious investigation. He rebuilt the device with greater precision, refined the internal geometry, controlled the variables more carefully, and measured the outputs with instruments calibrated to a standard that left no room for the measurement error excuse. What he found did not just confirm Ranke's original observation, it demolished every argument against it. The temperature separation was stronger than Ranke's crude original setup had captured. The cold end was colder. The hot end was hotter. The effect was not marginal. Under proper conditions, it was dramatic, powerful, and completely reproducible. Hilsch documented everything with the kind of methodological rigor that the scientific community could not dismiss. He published in 1947. The establishment finally paid attention. The device now carried both names permanently. The Ranque-Hilsch Vortex Tube, a quiet acknowledgement that the truth had needed two men across 2 decades to finally become undeniable. But here is where the story takes its most important and revealing turn. While scientists debated the theoretical mechanism in journals, industry made a different kind of decision. Engineers do not wait for complete theoretical consensus. They wait for reliable results. And the vortex tube produced reliable results, with a simplicity that made every alternative look unnecessarily complicated by comparison. Aerospace manufacturers, operating in environments where every gram of weight matters, where mechanical failure carries catastrophic consequences, where refrigerant leaks are dangerous and electrical cooling systems add unacceptable complexity, discovered that the vortex tube cooled critical components without any of those liabilities. No moving parts to fail under vibration, no refrigerant to leak in a pressurized cabin, no electrical cooling circuit to add weight and draw power. Precision machining facilities found that a focused cold air stream aimed directly at cutting tools during high-speed operations prevented the microscopic thermal expansion that ruins tight manufacturing tolerances, achieving better results than liquid coolants, without contamination risk, without disposal cost, without any of the infrastructure a liquid system demands. Electronics manufacturers deployed it to protect sensitive components during continuous high-load operations. Industrial workers in extreme heat environments wore vortex-cooled protective suits. Our welding operations used it in spaces where conventional fans would spread hazardous fumes rather than remove heat. All of this happened quietly, practically, without announcement. No press releases, no consumer marketing campaigns, no primetime advertisements explaining that a $150 device with no moving parts could provide industrial-grade cooling without electricity, without refrigerant, without maintenance contracts. Because the companies selling you refrigerant, maintenance contracts, replacement parts, and annual service visits had built an ecosystem worth hundreds of billions of dollars annually. And a device that needs none of those things was not a product opportunity. It was a threat. Today, some of the most technologically advanced manufacturing operations on Earth, aerospace facilities, precision instrument manufacturers, advanced electronics production lines, treat the Ranque-Hilsch Vortex Tube as an unremarkable standard tool, something in the supply cabinet beside the wrenches. Useful, dependable, completely ordinary to the engineers who use it daily. To the homeowner paying their summer electricity bill, it remains completely invisible. That gap is not an accident. That gap is the product of a market that profits from your not knowing. 100 years old. Refined and proven by the 1940s. Adopted across aerospace, precision manufacturing, and advanced engineering for decades. No moving parts, no refrigerant, no electrical cooling mechanism. Commercially available today for the cost of a dinner out. So why have you never heard of it? And more importantly, if you cannot use it to cool your entire home, what can you actually use it for? What are the real limits nobody mentions when they describe this device? And what does the physics happening inside that spinning chamber actually look like at the molecular level? Hold it in your hand. It weighs almost nothing. Every surface is visible. Every dimension is examinable in 15 seconds of casual inspection. There is no hidden compartment, no chemical reservoir, no internal mechanism waiting to be revealed by removing a panel. Just hollow metal. 2 exits, 1 inlet. That is everything. No motor hidden inside the body, no wiring running through the walls, no refrigerant circuit cycling through internal channels, no moving parts of any kind. Not a gear, not a piston, not a fan blade, not a single rotating shaft anywhere in its construction. If you cut it open and looked directly into the chamber, you would see nothing but empty space. And yet, connect it to compressed air, and one end drops to temperatures that freeze moisture on contact, while the other simultaneously rises to temperatures that cause burns within seconds of skin exposure. Your common sense will reject this. It should. Because common sense is constructed from a lifetime of observing that powerful effects require complex causes. Every cooling system you have ever encountered has confirmed this rule. Refrigerators, air conditioners, industrial chillers, every single one contains motors, chemicals, electrical systems, moving components, all the complexity that serious cooling seems to demand. The vortex tube has none of it. And it works better than many systems that have all of it. That gap between expectation and reality is not a magic trick. It is physics operating in a domain that conventional engineering chose to ignore because the conventional path was already profitable. What happens inside that hollow metal chamber is not mysterious, but it is extraordinary. And understanding it requires going somewhere most explanations of this device never actually take you, inside the spin itself. The moment compressed air enters the vortex tube through its angled side inlet, the transformation begins. Not gradually, not after a warm-up period, but instantaneously and violently. The inlet angle is not decorative, it is the entire mechanism's ignition system. Air entering a straight tube travels forward. Air forced through an angled inlet is immediately redirected into a rotational path, spinning around the inner wall of the chamber rather than traveling through its center. That seemingly small geometric decision creates consequences that cascade through the entire thermal separation process. As the spinning air moves through the chamber, the tube's internal geometry amplifies its rotation. What begins as fast becomes extraordinary. The rotational speed of air inside an operating vortex tube can exceed 1 million revolutions per minute. Consider what that number actually means. The most violent tornado ever recorded on Earth rotates at roughly 300 miles per hour. Jet turbine blades, precision-engineered components in the most powerful aircraft. Engines ever built operate at speeds that engineers spend careers optimizing. The air inside this $150 metal tube you can hold in one hand spins at intensities that make atmospheric storms look leisurely by comparison. But what makes this internal tornado genuinely revolutionary is not its speed. It is its structure. Unlike a natural tornado, a single chaotic column of rotating air with no internal organization, the vortex inside this tube develops distinct thermal layers. The outer ring of spinning air pressed against the inner wall by centrifugal force moves at the highest velocity. The inner core, sheltered from the aggressive outer pressure by the layers surrounding it, rotates more slowly. Two regions of air, same original temperature at the moment of entry, already beginning to diverge thermally within milliseconds of the spin beginning. This is the layered tornado. And it is where physics stops being abstract and starts being visible as temperature on your skin. Here is the mechanism that makes the vortex tube simultaneously elegant and unsettling to understand. Every molecule of spinning air carries angular momentum, stored rotational energy proportional to its speed and its distance from the center axis. Physics demands that angular momentum be conserved. This is not a suggestion. It is one of the most fundamental laws governing how the universe behaves. When the geometry of the tube creates a pressure gradient that pushes outer molecules further from the center axis, those molecules slow their spin. Slowing down while moving outward means surrendering rotational energy. That surrendered energy does not disappear. It transfers to neighboring molecules through collision. Transferred kinetic energy between molecules is, by definition, heat. The outer ring absorbs these energy transfers, grows progressively warmer, and continues accumulating thermal energy as the process sustains itself. Simultaneously, molecules migrating toward the center axis are entering a region of lower pressure. Gas expanding into lower pressure cools. This is standard thermodynamics, the same principle that makes aerosol cans cold when you spray them. But the vortex tube amplifies this effect through the continuous energy transfer happening outward. The inner core is not just expanding into lower pressure, it is actively surrendering energy to the outer ring through the angular momentum exchange. Both processes drive the core temperature downward simultaneously. The result is a self-reinforcing thermal cascade. The outer ring gets hotter because it keeps receiving energy. The inner core gets colder because it keeps surrendering energy. Both processes amplify each other continuously as long as the air keeps spinning. At one end of the tube, a control valve partially blocks the outer hot ring from escaping. The air that cannot exit reverses direction, spiraling back through the center of the original vortex in the opposite direction. Hot air traveling one way, cold air traveling the other. Two thermal rivers flowing simultaneously through the same chamber without mixing, guided apart by nothing but geometry and the conservation of angular momentum. Physics is not being violated here. Physics is being cornered, forced by clever geometry into producing an outcome that looks impossible until you understand the mechanism driving it. This is where abstract physics becomes something your body understands immediately. At the hot exit of an operating vortex tube, air emerges at temperatures that can exceed the inlet temperature by 100 degrees Fahrenheit. Room temperature air entering the device can exit the hot end hot enough to cause a burn on unprotected skin within seconds. Industrial applications use this heat productively, drying, warming, preheating, extracting value from what would otherwise be wasted thermal energy. At the cold exit, simultaneously, air emerges cold enough to freeze moisture on contact with humid surfaces, cold enough to immediately numb exposed skin, cold enough to feel on a scorching summer day like pressing your palm against dry ice. One valve, one adjustment, complete control over where that 100-degree spread distributes itself. Tighten the valve at the hot end, and the cold exit temperature drops further. More extreme cold, less volume. The device prioritizes intensity over quantity, producing a sharper, colder stream for applications, requiring maximum temperature drop at a precise point. Open the valve wider, and cold air volume increases while the temperature rises slightly. More coverage, less extreme cold, suitable for applications requiring broader cooling across a larger target area. This single mechanical adjustment, one moving part in a device that otherwise contains a zero, gives complete thermal control without a thermostat, without a control panel, without software, without a technician's expertise. The response is immediate, not after a startup cycle, not after the refrigerant reaches operating pressure. The instant compressed air enters, both temperature effects are fully present. The physics engages at the speed of airflow, which, at over 1 million revolutions per minute internally, means the response from a human perspective is effectively instantaneous. No law of physics is being broken inside this tube. No energy is manufactured from nothing. The cooling does not appear from nowhere. It is reorganized from the compressed air itself, which carries the stored energy of whatever compressor pressurizes it. The vortex tube does not create cold. It separates thermal energy that already exists, directing heat to one exit and cold to the other with a precision that still surprises engineers encountering it for the first time. What makes it feel like a violation of physics is the container. We expect powerful effects to require complex machinery. We have been trained by a century of increasingly complicated cooling technology to associate serious thermal performance with serious mechanical complexity. The vortex tube refuses that association entirely. It uses geometry, shape, angle, dimension to direct invisible molecular forces into producing a visible, measurable, industrially useful thermal separation. The complexity is in the physics. The device itself is deliberately, almost provocatively simple, and that simplicity is precisely why billion-dollar industries never rush to put it in your home. Here is the complete honest truth about the vortex tube, including the part that enthusiastic demonstrations consistently forget to mention before the excitement takes over. The tube costs $150. The system required to run it is a different conversation entirely. Compressed air does not exist naturally inside your home. It must be generated by a compressor, a machine with a motor that draws electricity, a tank that stores pressurized air, fittings and hoses that connect to the tube, and filters that prevent moisture and contamination from degrading performance. That compressor is not quiet. It is not small. Depending on the cooling volume required, it may consume electricity at rates that compete directly with the conventional air conditioning system you were hoping to replace. The vortex tube itself, zero moving parts, zero maintenance, zero consumables, potentially decades of operation without a single service requirement. The compressor behind it, moving parts, regular oil changes if oil lubricated, filter replacements on schedule, moisture trap servicing, hose inspections, motor maintenance, and a noise profile that will dominate any residential space it occupies. This is not a fatal flaw, it is a context requirement. Industrial facilities running compressed air networks for other equipment barely notice the addition of a vortex tube. The infrastructure already exists, the compressor is already running, the tube simply adds a cooling capability to a system already paid for and maintained. Homeowners building from scratch face a different calculation, and that calculation is what separates the vortex tube's genuine industrial brilliance from the free cooling promise that its more enthusiastic descriptions sometimes imply. Nothing about cooling is free. The vortex tube simply moves where the cost lives, from refrigerant and maintenance contracts to compressed air generation. For some applications and some users, that trade is enormously favorable. For others, it changes nothing about the monthly expense. Knowing which category you fall into before purchasing the tube is the difference between a brilliant tool and an expensive disappointment. The title of this video asks a question with a deliberate question mark. Free cooling? Is it real? Here's the honest answer. Targeted free cooling for specific applications with existing compressed air infrastructure is genuinely real and genuinely remarkable. The vortex tube delivers immediate, precise, reliable thermal control to a focused point without refrigerant, without electrical cooling mechanisms, without maintenance contracts. For that specific use case, it is as close to free cooling as engineering currently offers. Ambient free cooling, lowering the temperature of an entire room or living space to human comfort levels, is not what this device does. Not because the physics prevents it theoretically, but because the practical requirements of filling a volume of air with cold output large enough for human comfort would demand compressed air volumes that make the energy calculation unfavorable compared to conventional systems. The vortex tube is a precision instrument. It cools a point, not a space, a cutting tool during machining, an electronic component under continuous load, a specific bearing running hot in industrial machinery, a localized area on a worker's body in an extreme heat environment. Everything 6 inches outside the cold stream remains exactly as warm as before. This is not a limitation to apologize for. Precision spot cooling is a genuinely valuable capability that conventional ambient systems cannot provide efficiently. Factories depend on it. Aerospace relies on it. Electronics manufacturing requires it. The Vortex Tube excels at the job it was actually designed to do. The disappointment only arrives when someone expects it to do a different job entirely. And that expectation is manufactured by descriptions that emphasize the remarkable without being complete about the specific. Now the answer to the question embedded in this video's title: did big companies hide the Vortex Tube? Not with locked doors and classified files. The hiding was quieter, more structural, and far more effective than any deliberate suppression could have been. The global cooling industry, air conditioning manufacturers, refrigerant suppliers, HVAC service companies, parts distributors, certified installer networks, generates hundreds of billions of dollars annually. But the sale of the unit itself is not where the deepest revenue lives. The deepest revenue lives in everything that happens after the sale. Refrigerant is a consumable that leaks slowly and requires professional recharging, a service call that cannot be done without certification in most regions. Annual maintenance contracts cover filter replacements, coil cleanings, capacitor inspections, and system checks that homeowners cannot perform themselves. Replacement cycles end every unit's operational life on a schedule that feeds manufacturers, distributors, retailers, and installers simultaneously. The entire ecosystem, refrigerant industry, service industry, parts supply chain, installer certification programs, is built on the assumption that cooling requires complex machinery that breaks, consumes chemicals, and eventually needs replacing. The Vortex Tube sells for $150 and potentially never needs servicing again. There is no refrigerant to recharge, no annual maintenance contract to offer, no certified technician required for any aspect of its operation, no replacement cycle to anticipate, no part supply chain to feed, no installer certification program to protect. From the perspective of a company whose quarterly revenue depends on the recurring maintenance model, the Vortex Tube is not a product. It is a problem. Nobody gathered in a boardroom and decided to suppress it. The market did something more powerful and more invisible than deliberate suppression. It simply had no financial incentive to promote it, and every financial incentive to promote the alternative. Marketing budgets flow toward products that generate ongoing revenue. Retail shelf space goes to products with recurring consumable sales. Consumer education follows where advertising spending leads. The Vortex Tube received none of that, not because it was hidden, because it was unprofitable to reveal. Convenience culture completed the work that market incentives began. Consumers want a thermostat they set and forget. They want a system a professional installs and another professional maintains. They want comfort delivered as a managed service, not physics they must understand, aim, and actively direct. The Vortex Tube asks something different. It asks you to know what you need cooled, understand your compressed air requirements, and engage with the tool rather than simply purchasing a subscription to comfort. That gap between what the device offers and what the market has trained people to expect is more powerful than any conspiracy. It is invisible, it is structural, and it has kept a 100-year-old invention quietly serving industry while most of the world keeps paying bills it might not need to pay. At least not entirely, at least not for every application. The Vortex Tube does not need to cool your living room to justify a century of existence. It needs to be in the right hands for the right problems. And those hands already know about it, which tells you something important about who the market has decided deserves access to this knowledge. Off-grid builders and homesteaders running compressed air systems for tools and workshop equipment already have the infrastructure the tube requires. For them, adding Vortex cooling costs $150 and delivers immediate, reliable spot cooling for machinery, sensitive electronics, and localized workspace relief without adding to their electrical load in any meaningful way. Garage mechanics and fabricators dealing with cutting tools, welding heat, and precision machining have always faced localized thermal problems that ambient cooling never solved efficiently. The Vortex Tube aims exactly where the heat is, responds instantly, and requires nothing beyond the compressor already running in the corner. Remote operations, mining equipment, agricultural machinery, communication infrastructure, and locations without reliable electrical supply or refrigerant service availability benefit from the Vortex Tube's absolute mechanical simplicity. Nothing to leak, nothing to recharge, nothing that requires a specialist to repair. The only maintenance requirement is keeping the compressed air clean. Electronics developers and small manufacturers testing components under continuous load have a precise, contamination-free, instantly responsive cooling solution that refrigerant-based spot coolers cannot match for immediacy or simplicity. Emergency and backup scenarios, and where conventional systems have failed and immediate localized cooling of critical equipment is necessary. Benefit from a device that requires nothing but compressed air and responds within milliseconds of connection. For all of these users, the Vortex Tube is not a compromise or a curiosity. It is the best available tool for their specific situation. More reliable, more immediate, more maintainable, and more cost-effective than any refrigerant-based alternative at the same scale. The market decided these users were the appropriate audience: industrial catalogs, engineering supply companies, specialty equipment distributors, the people who already know what they need and know where to look for it. The people who do not know what they need, the homeowners, the consumers, the general public, received a different message. They received the message that cooling requires complexity, complexity requires professionals, and professionals require recurring payment. That message has been consistent, well-funded, and enormously effective for a very long time. Here is what a century of the vortex tube's quiet existence actually teaches. Remarkable inventions do not die when they are ignored. They wait. The physics inside that metal tube is identical today to what George Ranque observed in 1931. The thermal separation is the same. The angular momentum exchange is the same. The layered tornado spinning at over 1 million revolutions per minute is the same invisible, ruthless, geometrically elegant process it has always been. Nothing about the fundamental mechanism has aged. Nothing about its core capability has diminished. What changed across that century was not the device. What changed was context, who needed it, what infrastructure surrounded their work, and whether the people who could benefit from it had ever been told it existed. You have now been told. The deeper lesson this story carries goes far beyond cooling technology. It is about the gap between what exists and what gets marketed, between what solves problems elegantly and what generates recurring revenue reliably, between the tools that industry quietly depends on and the products that consumers are loudly sold. That gap is not unique to the vortex tube. It exists across dozens of technologies, dozens of industries, dozens of categories, where the profitable answer and the elegant answer are not the same answer. The next time a problem feels like it has only one expensive solution, ask who profits from that being the only solution you know about. Ask what a century of patents, academic papers, and industrial supply catalogs might contain that prime-time advertising has never found profitable to reveal. The vortex tube was hiding in plain sight for 100 years. It was not waiting for someone to discover it. It was waiting for someone to look.